All right, ladies and gentlemen, we're going to start off with Chapter 6. With Chapter 6.1, we're going to be solving systems of equations, and that's what we're going to be doing this whole chapter, is trying to figure out where these two lines intersect. So that's the idea. It says two or more equations together are called a system. Here I have two systems here. X plus y is 500, and I have another equation here, 5x plus 2y equals 1,450. And what we're trying to do is we're trying to figure out where these two lines are equal. Okay, he says the solution to a system of equations is where the lines intersect. And one method to find the solution is to graph the equations on the same coordinate plane. The solution is an ordered pair where the lines meet or intersect. And that's going to be an x comma y. So we're going to graph some lines here. You might see lines that intersect just like here. And we're going to see that these guys might have the same slope or different slope. I don't know. Let's see. Different slope. The y-intercepts might be the same. They could be different. Just kind of depends. If they intersect at the same y-intercept, then they'll be the same. And if they intersect somewhere else other than a y-intercept, they will be different. And number of solutions, we're only going to find one. We're going to find that intersection right here at x comma y. If we have parallel lines, then we'll see that the slopes are the same. The y-intercepts will be different. And the number of solutions will be none. If you want to put a circle with a slash through it for the empty set, that works too. And then last but not least is what we call coinciding lines. For a line to coincide with another one just means it's a line on top of a line. So if I was to draw another red line right on top of it, you'll see that the slopes of these two lines will be exactly the same. You'll see the y-intercepts are the same. And the number of solutions, well, there's a point here they have in common, and a point here, and a point here, and a point here, and a point here, and a point here. So there's an infinite many that they have in common. So if you want to write IMS, infinite many solutions, that works too, or the infinity sign works for me. And the solutions will be on whatever that line is. So let's put this in action. Let's see where we can find and solve these systems of equations by graphing and talk about any special cases. Okay, so to get you thinking in the right frame of mind, we're going to give you a system here. We have x plus y equals 6, and then we have 2x minus 5y equals negative 2. And they want to see if these ordered pairs are solutions to these equations. So one thing we can do is we could graph them and see where it intersects. Or if they give us the points, we can plug them in here. Okay. So again, remember this represents an x and a y, so I'm going to plug those in for x and y. So as I take a look in the blue equation, I'm going to use x plus y equals 6. I've got 3 plus 3, x plus y equals 6. That checks off. That works. When I do the next one, anywhere there's an x, I'm going to put parentheses, and anywhere there's a y, I'm going to put parentheses. And I'm going to plug in that 3, 3 and see if it works. So plug in 3, 3 and see if it works, if it equals negative 2 on the other side. If I got 2 times 3, that's 6. Negative 5 times 3 is negative 15. And then I ask myself, is 6 minus 15 equal to negative 2? And the answer is no. So that one does not work. So this is a no for 3, 3. Well, now we want to check and see if 4, 2 works. So we go back to the blue equation, x plus y equals 6, and anywhere there's an x, I'm going to put in 4, and anywhere there's a y, I'm going to plug in 2 and see what I get. So as I take a look, I got x plus y, 4 plus 2, is that equal to 6? Yes. All right, so let's see if the red one works out. So the red one, again, is 2x minus 5y equals negative 2. I'm going to go ahead and rewrite that. Oh, that's a 2. I got 2 times parentheses minus 5. Y equals negative 2. And anywhere there's a x, I'm going to plug in that 4. And anywhere there's a y, I'm going to plug in that 2. Then I'm going to simplify and see what we get. So again, we've got 2 times 4. That's 8. And negative 5 times 2 is negative 10. And then I ask myself, is 8 minus 10 equal to negative 2? For sure. So that one checks out. So yes, it works for both of them. 4, 2 works for both. So 4, 2 works. This one, doesn't work. Okay. All right, so that's one way to do it. The other way to see if where these guys intersect is just go ahead and graph them. Okay, when I'm graphing, I always love to graph in terms of y equals mx plus b. That's my favorite way to graph, and that's probably one of yours too. So we're going to go ahead and graph this one, y equals 2x. It's ready to go. I know I have a b value because there's nothing back there of 0. Remember, we put our pencil on the b. It's going to be right there at the origin. And then my slope, rise over run, is 2. And think of that as a fraction, 2 over 1. I'm going to go up and to the right. So from b, from 0, 0, I'm going to go up 1, 2, and over 1. Up 1, 2, over 1. I like to do this quite a few times here just so I get a good, accurate graph. Okay. If you got your ID, that works great. If you got a ruler, that works great. If you got sticky notes, that works great. Boom. There's that first line. Well, now I want to see where this one intersects. Now, this one is standard form, and you could graph this in standard form, but a lot of times I don't like to do that. So what I'm going to do is I'm going to make this look like y equals mx plus b by moving this x over. So to do that, we're going to subtract the x. And now I've got y equals negative x plus 3. These are unlike terms. Can't put them together, so I leave them separate. So I take a look. My b is 3. So I'm going to go up 1, 2, 3. There's my b. And now I'm going to do my slope. Here I got a negative. Think of this as negative 1 over 1. Negative slope goes down and to the right. So put your pencil on the B. It's not hard, you see. Man, we're having fun. Now it's time for rise over run. Then we go, we will graph through. So we go down 1 over 1. Yes, there's the intersection right there. So I connect the dots. Here we go. And now my solution is where those two lines, the blue and the red one, intersect. So start at the origin and figure out what that coordinate point is. This is over 1 on the x-axis, so that's 1. And then it's up 1, 2. So 1, 2 is my coordinate point. Okay. All right, let's try number 3. On number 3, I've got y equals negative 3x plus 1. So we're going to put our pencil on the b. Y equals mx plus b. B is 1. So up on the y-axis. And then my slope is negative 3. Think of negative 3 over 1. I'm going to go down 3. 1, 2, 3 to the right 1. Down 1, 2, 3 to the right 1. Man, that's fun. Rise over run. Okay. If you want to go up and to the left, up 1, 2, 3 and to the left, you could do that. 1, 2, 3 and to the left. That way it has that nice negative slope, just like Slope Dude says. Okay. Technically, you only need 2 points, but to get a nice, accurate graph to find out where these guys intersect, that's what we're looking at. All right, now the next one. Man, I don't like how this thing looks. Okay. I've got x's and y's on the same side. I want y by itself. So I'm going to go ahead and subtract this x over. So this is what I've got. I've got a positive 1/2 y equals negative x, and then minus 1/2. So there is a minus sign there. So minus x minus 1/2. Well, over here, as I take a look, there's a 1/2 still in front of this y. So what I want to do is I want to get rid of that. Think of this as 1/2 times y. I want to either divide by 1/2, or we talked about keep, change, flip. I can go ahead and multiply everything by 2 over 1 or 2. So multiply by 2 over 1 or 2. And what happens is these will cancel. And now I get y equals 2 over 1 or 2 times negative 1 is now negative 2. And 2 over 1 times negative 1/2 is just now negative 1. So now I'm going to graph this guy right here. All right, so I'm going to go down 1 right here, which is not an intersection point. I'm going to go down 2, 1, 2 over 1. Down 1, 2, oh, right there is the intersection point. Okay, where the blue and the red one meet. It was really close right here. It wasn't quite that dot. That's why I like to graph these a few times, especially if my line's not perfectly up and down those lines like I want. So again, they share this point right here. Okay. Now I got to figure out what that coordinate point is. So I'm going to count over 1, 2 to the right on the x-axis. So that's positive 2. And then I'm going to count down 1, 2, 3, 4, and 5. That's negative 5 for the y. So 2, negative 5 is the solution. All right, so far so good. Here we go. Moving on to the next ones. All right, so let's see some special cases here. So as I take a look at number 4, I've got x minus 2y equals 4. Again, I always like to put it into y equals mx plus b form. So I'm going to move this x over using subtraction. I'll do this one in blue here so you can see it. So that gives me negative 2y equals negative x plus 4. And now I'm going to divide by negative 2. And this is donuts. If you do it to one, you got to do it to everything. Negative over negative cancels here. We get y equals negative over negative is a positive 1 over 2x. And then my b value is 4 divided by negative 2 is negative 2. So there's my equation there. Put my pencil in the b. B is negative 2. So do we go up 2 or down 2? It's negative, so we go down. And then b's done. Now my slope, my rise over 1, I got 1 over 2. So I'm going to go up 1 over 2. If you want to do it again, man, that's fun. Rise over run. So up 1 over 2. All right, so I graph my nice pretty line here. And now I want to see where the other one intersects. As I take a look, this one is also in standard form. I want to make it look like slope-intercept, so I'm going to subtract the x over. I'm going to do my work off here on the side. I've got negative 2y. These are unlike, so I'm going to leave them separate. Put the x first, so it's negative x minus 2. And now I'm going to get rid of this negative 2 times y by dividing by negative 2. And it's donuts. If you do it to one, you got to do it to everybody. Bring in donuts for one person, you got to bring them in for everybody. It's only fair. So negative, think of this as negative 1 over negative 2 is positive 1/2. And negative 2 divided by negative 2 is plus 1. So I'm going to go up b. B is 1 at the end. I'm going to go up b. And then do you see the slopes? Look at the slope of this one and the slope of this one. What do you notice? They're the same. So as I go up 1 over 2, up 1 over 2, you could keep trying and trying and trying, but you will never, ever, ever intersect that line. So the question is, where do they intersect? And you guessed it, nowhere. Why? What kind of lines do we have? We've got parallel lines. Anytime we have parallel lines, we have no intersection. Okay, so that's a special case. If you notice that the slopes are the same, no solution. We'd still want you to graph those so you can kind of prove or show us why they're not any solutions. Okay, and that's because they have same slope. All right, ladies and gentlemen, you're on the last one for today. So here we go. I'm going to go ahead and solve 3x minus y equal to 2 and put that into slope-intercept form. I'm going to move this x over. So now I've got a negative y equals negative 3x plus 2. Don't make that negative disappear. The only way to do that is to use division. And if you divide one, you got to divide them all. So now I've got y equals negative over negative is a positive 3x, and 2 divided by negative 1 is now negative 2. So I've got y equals 3x minus 2. Put my pencil on the b. B is negative 2. I'm going to go down 2 on the y-axis for the y-intercept. And my slope is 3. Think rise over run. Think 3 over 1. So I'm going to go up 1, 2, 3 over 1. If you wanted to do it again, 1, 2, 3 over 1. Again, you only need to do 2 points, B and a point from B using your slope. You can do as many as you want. There we go. Nice little line right there. Okay. Last thing we got to do, ladies and gents, is go ahead and graph this guy right here. Okay. Again, you could use the cover-up method. I don't really like doing that. I want to see what I get doing slope-intercept. I like seeing the slopes and seeing what I get. So I'm going to go ahead and subtract this 12x over. So these cancel. I'm going to work over here. I've got negative 4y equals negative 12x plus 8. I got one more step. I'm going to divide by negative 4 to everything. I end up with y equals negative 12 divided by negative 4 is a positive 3x, and 8 divided by negative 4 is a negative 2. I take a look and I go, oh my gosh, look at this. These are exactly the same. My b value is negative 2. My slope is 3 or 3 over 1. And I get the exact same line. So I get a line on top of the line. We call these coinciding lines. Okay. You can barely even see that red one on top. And you ask yourself, what points do they have in common? Well, they got this one and 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 that one. There's an infinite many solutions. If you want to use the infinity sign, you can. I'll probably use IMS mostly. Okay. So, ladies and gentlemen, that is it for Chapter 6.1. Again, looking to solve systems of equations using graphing method. If you guys have questions, I'll be back soon. Talk to you later. Happy Thanksgiving.